everyone. Welcome to episode number 628 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. My guest this week is Giovanni Garcea, president of AnDAPT. Giovanni and I are talking about the details of AnDAPT's field programmable PMIC and how engineers can take advantage of AnDAPT's programmable power solution that is designed with AI called PMIC.AI. Also this week, I check out a new fluid battery that can take any shape, developed by researchers at Linköping University. But first, please welcome Giovanni from AnDAPT. Hi, Giovanni. Thank you so much for joining me.
Hi, how are you?
I'm great. How are you?
Very good, thank you.
Excellent. Okay, so first off, talk to me about AnDAPT and what you guys are all about.
We're all about flexibility in power management. We think that PMICs, that are the key of power management in complex platform solutions, are now too difficult to obtain and only available for very high volume application. What we're all about is to bring PMIC experience and flexibility in all the possible projects, even projects that have low volume or cannot afford a large NRE.
Fantastic. All right. So I'm really interested in your field programmable PMIC. So walk me through the elements of this solution.
Our solution is fairly complex, but very easy to use from outside. We have a programmable PMIC that does a dual fabric interconnect, digital and analog. This enables integrating power, analog, and digital functionality in a very small package. Right now, it's a 5x5 QFN. We have voltage reference, comparators, compensator memory, MOSFETs, drivers, anything that you need to build a power supply, and we connect it together with our FPGA core. So we can implement buck, boost, LDO, load switches, multi-phase thermos controller. Pretty much any power IP that might be needed in a modern solution can be enabled and implemented with our programmable PMIC.
Fantastic. All right. So, Giovanni, I was also really interested in your PMIC.AI. So, tell my audience more about this programmable power solution that is designed with AI.
Yes, this is our way to bring AI and our technology together. So we build this tool based on a large language model and use retrieval, augmented generation, and fine-tuning to provide cutting-edge power management solution. Basically, at high level, we compacted and put all the experience of all our application engineers inside this model, and we can automatically add any power solution starting from a customer requirement. Basically, we do automated power tree analysis, intelligent rail sequencing, advanced compensator selection, and basically a single-click design visualization. The customer just put this requirement, and instead of spending hours or weeks, either alone or with the help of an application engineer, in a minute, we provide a full power solution with full visualization.
All right. So, Giovanni, tell me a bit about your WebAMP RD tool.
WebAMP-RD, it's a different way to implement designs quickly. RD stands for reference designs. It's a way for us to bring to customers ready-to-use design for popular SoCs, specifically FPGAs. What does this tool do? This tool enables the customer or the user to just select the FPGA or any other SoC that I may be using, the SKU and the power use case that they want to implement in their system, and we automatically give a design ready to go with all the programming files, documentation, power performance characteristics, and the customer is up and running with a very complex design in minutes.
Fantastic. That's great. Okay, so you guys have a power management platform as well. So talk to me about that.
In the end, our power management platform is the combination of our unique silicon technology and our advanced design tools. In our chip, we have monolithically integrated the proprietary FPGA core that we use to interconnect analog, digital, and power blocks and to create state machines. So this allows us to create virtually any power solution. The beauty of it is that the complexity that I can guarantee you is very high inside the chip is all handled by one of our design tools. And we have a few. We have WebAmp, we have WebAmp RD reference design, and we have the new AI, PMIC.AI tool. This makes our platform the most flexible, but also the simplest power management solution on the market, in our opinion.
Okay, so for my audience who wants to get started using your solutions, you guys have some hardware demo boards as well, right?
Of course we do. We have many eval boards because we know the engineers love hardware, love playing with it, love starting right away. So we have several demo and evaluation boards that are available to test our device. We have user guides. We have videos on YouTube to how to start using it. The boards and the bring up guides are all available on our website. Please go on our website and you'll find all types of solutions.
Fantastic. All right, Giovanni, it's time for your off the cuff question. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
Oh, no, I don't need a passport. It's 6:30 p.m. for me, and I live in Barcelona, and I'll have a pizza.
Nice. What a good choice. Awesome. Well, Giovanni, it was a pleasure speaking with you. Thank you so much for joining me.
Thanks to you, Amelia. It was great.
Have you heard about the new fluid battery developed at Linköping University in Sweden? All right, so get this. By using electrodes in a fluid form, researchers at Linköping University have developed a battery that can take any shape. And this soft and malleable battery can be integrated into future technology in a completely new way. Assistant professor at Linköping University explains their research like this. Batteries are the largest component of all electronics. Today they are solid and quite bulky. But with this soft and conformable battery, there are no design limitations. It can be integrated into electronics in a completely different way and adapted to the user. Interesting, right? So, this team says that their new conformable fluid battery material has the consistency akin to toothpaste and can be used in a 3D printer to shape the battery into a variety of different sizes and shapes. And the key here? Converting the electrodes from a solid to a liquid form. So, previous attempts to manufacture soft and stretchable batteries have been based on different types of mechanical functions, like composite materials that can be stretched out or connections that slide onto each other. But at the core of that previous research is still a problem. That being, a larger battery has a higher capacity, but more active materials means thicker electrodes and thus higher rigidity. There has been a movement in the field of fluid electronics in the last several years as well, without much success. Those experiments used liquid metals like gallium, but then that material can only function as an anode and has the risk of being solidified during charging and discharging, which makes it lose its fluid nature. Also, very importantly, many of the previously made stretchable batteries used rare materials. And well, we all know how bad that is on a bunch of different levels. So instead, these researchers have based their soft battery on conductive plastics and lignin, which is a byproduct of paper production. And get this, their new battery can be recharged and discharged over 500 times and still maintain its performance, and can also be stretched to double its length and still work just fine. Mohsin Mohammadi, one of the lead authors behind the associated research article published in Science Advances, says this about the composition of their new battery technology. Since the materials in the battery are conjugated polymers and lignin, the raw materials are abundant. By repurposing a byproduct like lignin into a high value commodity such as a battery material, We contribute to a more circular model, and so it's a sustainable alternative. So this team does need to increase the electrical voltage in the battery. And they explain the next steps forward like this. The battery isn't perfect. We have shown that the concept works, but the performance needs to be improved. The voltage is currently 0.9 volts. So now we'll look at using other chemical compounds to increase the voltage. One option that we are exploring is the use of zinc or manganese, two metals that are common in the Earth's crust. So obviously, this technology is not ready for prime time just yet, but I think it signifies a big movement toward new sustainable battery technologies. And I'm excited to see where this technology could be headed from here. So, if you want even more information about this new fluid battery technology or more information about AnDAPT, I've included a bunch of links below the player on this week's Fish Fryin' page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is more your thing, I dig it. You can follow me or us on LinkedIn as well. And we are also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our new animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. Also, make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to some exciting upcoming episodes. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of April 18th, 2025, I'm Amelia Dalton, and you've been fried.